Level 0. At level 0, volcanic eruptions are not explosive. Instead of violent blasts, the volcano produces steady flows of lava. These eruptions typically cause minimal damage and pose low risk to life, although lava flows can still destroy property. A well-known example is the frequent eruptions of Mauna Loa and Kaʻlauea in Hawaii. The eruption column is less than 330 feet high, and the volume of material ejected is under 13,000 cubic yards. Level 1. Gentle eruption. V1 eruptions are mildly explosive. They can produce small ash clouds and occasional lava fountains, but their impact is usually localized. These eruptions may form small volcanic cones and can be more of a visual spectacle than a danger. Ash columns typically reach heights of up to 3,300 feet, and the volume of ejected material ranges from 13,000 to 1.3 million cubic yards. Stromboli, in Italy, often has eruptions of this type. Level 2. Explosive eruption. At VEI2, eruptions become clearly explosive. Ash columns reach up to 3.1 miles into the atmosphere, and the eruption can distribute volcanic ash over tens of miles. While these eruptions are still considered small on the scale, they can affect air travel and disrupt nearby communities. The ejected volume is between 1.3 and 13 million cubic yards. Mount Etna has had multiple eruptions in this range. Level 3. Severe eruption. VE3 eruptions are significantly more powerful. Ash plumes can rise between 1.9 and 9.3 miles into the sky, often accompanied by pyroclastic flows or lava domes. These eruptions can damage infrastructure and spread ash over hundreds of miles. The volume of ejected material is between 13 and 130 million cubic yards. An example is the 2008 eruption of Mount Okmok in Alaska. Level 4. Cataclysmic eruption. VE4 marks the beginning of large-scale explosive activity. These eruptions can send ash columns 6.2 to 15.5 miles high and cause widespread destruction. Ashfall can blanket entire regions, disrupt global air travel, and affect weather patterns. The volume of ejecta is between 130 million and 1.3 billion cubic yards. The 2010 eruption of Eyjafjallajökull in Iceland is a well-known VE4 event. Level 5. Paroxysmal eruption. VE5 eruptions are rare and dangerous. They eject over 1.3 billion cubic yards of material and produce ash clouds over 15.5 miles high. These eruptions are capable of causing regional catastrophes, including fatalities, climate effects, and massive evacuations. Mount St. Helens in 1980 is a classic example of a VE5 eruption. Level 6. Colossal eruption. VE6 eruptions are enormous and globally impactful. With more than 13 billion cubic yards of material ejected, these events produce ash columns that can exceed 18.6 miles. Climate disturbances, like global cooling, are possible. The 1991 eruption of Mount Pinatubo in the Philippines released enough sulfur dioxide to lower global temperatures for several years. These eruptions happen only a few times per century. Level 7. Supercolossal eruption. VE7 eruptions are among the most powerful in human history. They produce over 130 billion cubic yards of ejecta and have devastating effects on climate, agriculture, and civilizations. Ash and gas reach into the stratosphere, causing long-term global cooling. The 1815 eruption of Mount Tambora in Indonesia is a VE7 event and caused the year without a summer in 1816, leading to famine and social unrest around the world. Level 8. Megacolossal eruption. VE8 is the highest level on the scale and represents supervolcanic eruptions. These events are extremely rare and catastrophic on a planetary level. They eject more than 1.3 trillion cubic yards of material and can blanket entire continents in ash. Climate effects can last for decades, potentially triggering mass extinctions. The last known VE8 eruption was the Toba supereruption in Indonesia about 74,000 years ago, which may have caused a global volcanic winter and nearly wiped out early human populations. And if you liked this video, subscribe and check my socials where I'm documenting my progress journey. Link in the description. See you in the next video.